Study about addition and subtraction of complex numbers. Let us see complex addition. In complex addition, we add the real parts of the two complex numbers to be added, which can be written as real part of z1 plus z2 equals real part of z1 plus real part of z2. Similarly, for imaginary part, we can write imaginary of z1 plus z2 equals imaginary of z1 plus imaginary of z2. Let z1 equals a plus iota b and z2 equals c plus iota d be any two complex numbers, then the sum z1 plus z2 is defined as follows. z1 plus z2 equals a plus c plus iota times b plus d, which again a complex number. Let us see an example of complex addition. Here we have two complex numbers. The first one is 3 plus 4 iota and the second one is minus 1 plus iota. Their sum would be 3 plus 4 iota plus minus 1 plus iota. Now we add the real parts and we add the imaginary parts. So we get the sum equal to be 2 plus 5 iota. Let us study properties of complex addition. The first one is the closure law. The sum of two complex numbers is a complex number. That is, z1 plus z2 is a complex number for all complex numbers z1 and z2. The commutative law. For any two complex numbers z1 and z2, z1 plus z2 equals z2 plus z1. The associative law. For any three complex numbers z1, z2 and z3, z1 plus z2 taken at once added with z3 equals z1 plus z2 and z3 added at once. The existence of additive identity. There exists the complex number 0 plus iota times 0, which is denoted as 0, called the additive identity or the zero complex number, such that for every complex number z, z plus 0 equals z. The existence of additive inverse. To every complex number z equals a plus iota b, we have the complex number minus a plus iota times minus b, which is denoted as minus z, called the additive inverse or negative of z. We observe that z plus negative of z equals 0. Let us study subtraction of complex numbers. If z1 equals a1 plus iota times b1 and z2 equals a2 plus iota times b2 are two complex numbers, then their subtraction z1 minus z2 equals z1 plus negative of z2, which is equal to a1 minus a2 plus iota times b1 minus b2. Let us see the graphical representation of complex subtraction. Here we have two complex numbers z1 and z2. Here z1 is in the first quadrant and z2 is in the third quadrant. We'll take negative of z2 and represent it in the first quadrant as shown in the figure. Then we can add z1 and negative of z2 to get z1 minus z2. Let us take an example. If z1 equals 2 plus 3 iota and z2 equals 3 minus 2 iota, then find z1 plus z2. Note the solution. z1 plus z2 equals 2 plus 3 plus iota times 3 minus 2, which is equal to 5 plus 1 times iota, or 5 plus iota. Let us take another example. If z1 equals minus 2 plus 3 iota and z2 equals 4 plus 5 iota, then find z1 minus z2. Note the solution. z1 minus z2 equals minus 2 minus 4 plus iota times 3 minus 5, which is equal to minus 6 minus 2 iota.